of a picture, right? So the school has to build a wheelchair ramp outside the front doors, okay? The current stairs go through a vertical rise of 1 meter, okay? If the ramp has to be 14.6 meters long, how far from the school will the ramp start, okay? So there's a lot of information in there, but if you dissect it in one stage at a time, right? School has to build a wheelchair ramp outside the front of the school, okay? That doesn't tell us anything, right? So aside from the fact that we're trying to build it as a school, so why don't we just say, okay, here's our school here, okay? Or this is like kind of the top, right? And then we're saying, okay, well, this is a rise of 1 meter, right? Top to bottom. Okay. All right, let's keep reading. If the ramp has to be 14.6 meters long, okay, the ramp itself, remember? The ramp is not going to run from the base. The ramp is going to run from the top of the stairs down to the ground. That's saying this has to be 14.6 meters long. Okay, the question is asking us how far from the base of the school does the ramp need to extend out, right? Okay, so I'll just highlight the question or where the information came from their respective, like, okay, so we can see where all this information came from. Okay, does anybody have any questions with that picture? All right. The school again meets the ground at a 90-degree angle, so you know where the big one, like the big side length is, right? And the big angle. This is going to be C and that's C. This is where I start all the time, right? Then you're saying, okay, well, it doesn't matter how I label the other two. I could say this is going to extend out too. Okay, this is going to be like A, which makes this A, and up top here is going to be B. So it looks like the side length I'm interested in is side length B. Okay, so that's what we got to solve for. So let's do that. Well, how do I solve for that? Well, it looks like I have a 90-degree. That's check 1. And then I have 2 of the side lengths. Well, this sounds like a Pythagorean theorem question. If I were to write out a squared plus b squared equals c squared, it looks like I can check off 2 pieces of information, right? I know what A is, and I know what C is. So you just plug it in and solve for the third. Okay, so let's plug it in. 1 goes in for A plus b squared, which I don't know, is equal to 14.6 squared. Okay, 1 squared is just going to be 1 plus b squared equals, I don't know what 14.6 squared is, so we'll pull up our calculator. We say, okay, 14.6 squared, 213.16. What do we have to round to? We'll round our final answer to the nearest tenth, okay? But carry this one, because we saw yesterday too, if you round early and you round in every step, your answer gets further and further off, right? Okay, so we're like, okay, how do I get b by itself? Well, we just deal with the subtraction first, right? We got to move that over, so it's going to be 213.16 minus 1. B squared is going to equal 212.16. Now we have to square root both sides. All right, so b equals, it's the square root of that. Well, that's on, oh, that's, of course it's that. That was the answer. 212.16. You gotta square root that. Okay, it looks pretty close to the same answer, but it's 14.56. We'll write it to the hundredth, just so we can see that there's a difference. Okay, it's not a huge difference, right? That's particularly because we're only going up 1 meter. Okay, if we did this question again and the ramp was going like I don't know, if it was going 3 meters up, that would make a bit of a difference, right? Okay. I'll write it to the 100th because we can see, we know what 14.56 means. It's 56 centimeters, right? It's only a difference of 4 centimeters for this particular question, okay? Not a huge difference. But we will do questions where there is a significant difference, okay? Or at least that we saw this question up top here, right? Height of the school. The height of the school is much different than the two measurements that I provided, right? Okay. Anybody have any questions? I put a